All right. Hello, everybody. My name is Stefan Plantikow. I'm the editor for GQL, the graph database language standard that Keith just introduced. In my day-to-day life, I work at Neo4j in the Langster group that has been, I think, quite instrumental in the creation of GQL. And I want to talk a little bit about the more technical side of GQL. You know, what's in the standard? What features are you going to get? How does the syntax look like? And of course, a lot of things will fall by the wayside, given that the talk is 15 minutes long. Yeah, just a short safe harbor statement. Today, I'm really speaking here in my role as GQL editor and not on behalf of Neo4j. So please don't take any of this as any kind of product roadmap type of information. What is GQL? Well, Keith already introduced it, right? It's a new standard done by the SQL committee for an ISO graph query language standard. We are now a DIS. That means we are technically complete. It was initiated, if memory serves correctly, now 5 years ago by Alistair's GQL manifesto. And of course, behind that manifesto was the recognition that there is growing property graph adoption, right? It keeps being adopted because it's practical and works for people. And there's also a lot of commonalities between graph query languages in existence, but there is not a single one, right? And so we set out to do the standard. What's the 10-mile high view? GQL is a complete database language that means it has a query language, you can modify data, it has a DDL language. Syntactically, it follows the tradition that we know from SQL. So you have like, keywords usually written in all caps, right? So somewhat human readable syntax. It does, though, allow both the select style that people know from SQL, which is a bit backwards, where you first say what you want and then you kind of go down. And it also allows the style based on return known from Cypher, where you slowly, incrementally build your result up top to bottom. From an execution model perspective, we have things you would expect in a database language, like sessions, transactions, requests, and things like that. The data model is, of course, a labeled property graph model. And I think it's worthwhile that this is standardized also as part of this effort, right? Because there wasn't a real standard of the property graph model before, right? Every vendor had like slightly own ideas of what that actually means, right? And maybe also kind of next to the data model, what comes with GQL is the notion of a hierarchical catalog for accessing data objects, right? That is also something that I think some languages had it, but certainly not all languages had that. The access paradigm for data access is pattern matching into binding tables. So we describe graph patterns and get bindings out. We have the ability to both use work schema-free or use a mandatory schema. And data types are very much oriented for compatibility with SQL, but of course do not take the whole set of SQL capabilities, but are a bit more, let's say, future-leaning by demanding things like Unicode, by defining floats to be aligned with IEEE 754, by using ISO 8601 template types and things like that, right? I want to double-click on all of these points a little bit in this presentation today. So let's get started. So as I said, GQL is a complete database language. Here we have a bit in a nutshell. This is kind of like a syntax, a very high-level syntax cheat sheet, right? So you see, we can pattern match, we can bind variables, we can unbind lists, we have order by, we have calling of nested subqueries, right, on the querying side. On the DML side, we have things you would expect, kind of CRUD, inserting nodes, deleting nodes, setting labels, properties, removing them, right? On the DDL side, we have commands for manipulating essentially the structure of the catalog, creating graphs, creating graph types, and so on. We have commands for modifying sessions and for working with transactions. To make that a bit more concrete, a little taste of GQL. Here's an example, right? A bit full-blown example, perhaps. So we start with setting a session level parameter here, $country to MA, which is the country code for Morocco. So if you're interested in joining standards efforts, that's where the next WC meeting will be in September. Then we start a transaction, start transaction, just like you would do in SQL. And then here in the line marked as 1, the actual query starts. We use a social graph. So here that indicates that's the graph we want to work with. Then we do pattern matching. Here we have a pattern that finds essentially friends of a friend, where the basically the friend P is younger than the friend F, and the friend F needs to come from the country, which is in this case Morocco, right? And then we materialize those edges here. So we're creating essentially friend of a friend edges in our graph and do aggregation. we return the number of added edges, right? And then we commit the transaction and close the session. And here we have a good example of a GQL query that makes use of multigraph, that makes use of pattern matching, that makes use of DML, and also showcases a bit the existence of sessions and transactions, right? We could also write our queries in a select style. I already said that. I don't want to, go into the details of that, but that's also supported. Here's a slightly different example of that. So that may look like quite a lot, right? I showed all the syntax and all that stuff, but one of our goals certainly for GQL is that it is a standard for many different implementations, as many as possible, right? And the way that we achieve that, the WG3 has achieved that before with SQL, and we want to follow that for GQL, is that the standard provides a high degree of featureization, right? So it is possible to write a very minimal, but nevertheless conformant GQL implementation that only supports a single ambient graph, that only supports a minimal set of essential data types like strings, integers, floats, and booleans, that only supports basic, essentially join-like pattern matching and read-only transactions. And if you did that, you would have a conformant GQL implementation possibly, right? And with that relatively small set of capabilities, it becomes possible to expose any data as a property graph, right? If you have a big data asset and you just want to expose it as a property graph, that would be possible, right? Of course, of the other end of the spectrum, and of course, as the editors and the people behind creating GQL, that's what you want to see. There's also quite possible to create fully fledged implementations that have all the bells and whistles and all the advanced conformance features the standard has to offer. Execution model. So yeah, it gets a bit more formal here. So how do we think about things? Well, the important concept is a GQL environment. This is really where all the different components of the system come together. And that is also the unit by which conformance of implementations is understood. And what basically happened is that the GQL agent, which you can think of as an application program, instructs a GQL client, which you can think of as something like a JDBC driver, to send a GQL request to the GQL server on behalf of the user, right? And then the server goes and executes the request and delivers an outcome back via the agent to the client, right? That's the whole workflow. We currently don't have a CLI, although many people, I think, are interested in that being standardized, and discussions are already beginning to be underway on how that might happen. So what is a request? Well, a request is essentially a piece of text, a valid GQL program if it passes correctly, and a set of parameters that go along with it. And then a program can be all these things I showed earlier, right? Session commands, transaction commands, or proper queries, which in GQL are actually called procedures, right? The terminology is a bit different from SQL there. So how do they get executed, when they get executed? So the basic semantic execution model for people interested in semantics is we have a stack of context, right? We have a session context for all the state associated to a session. We have then a context that's called request context, which has the request parameters and things like that. And then the main part is an execution stack of execution context. And what do we find in execution context? We have a working record of variables that are already bound. We have a working table of essentially data that we are going to be iterated on by the execution of a statement or a procedure. And then, of course, we have an outcome, right? And in particular, I would like to talk about the last point, what is actually the result that comes back from GQL. Well, we have a status code, quite similar to SQL, well-defined status codes and error diagnostics in case something goes wrong. And then we have the actual result, and first and foremost, that is a tabular result, because most existing graph query languages like to consume applications like to consume their results in tabular form, but in principle, it is also possible to return values, including reference values, and reference values also includes the capability to include references to graphs, right? So while that is not fully developed, so GQL is already prepared to be extended towards graph compositionality. We also have a notion of an omitted result that is returned on successful DML. Hierarchical catalog. I mentioned it. It's one thing to standardize the data model, but in a practical language, you usually want to have more than one of that data model. And so because of that, also quite similar to SQL, we have the notion of a hierarchical catalog that is structured in a nested tree of directories. Leaf directories are called schemas, and schemas contains the actual data objects, the actual graph that you might want to access from your query, right? And here, again, there's a lot of flexibility. Implementations are at liberty to kind of go with a very simple catalog structure, go with a really complex catalog structure. It's possible to essentially emulate the structure of SQL. right? So there's a lot of flexibility given here for how implementations want to use that. Speaking of the data model, I already mentioned it. The data model that we have standardized labeled property graphs in its full generality consists of nodes or vertices and relationships or edges, which have a syntactic identity, which can have 0, 1 or more labels, which can have 0, 1 or more properties. And that's kind of it. It's a multi-graph model, so there can be multiple edges between the same pair of nodes that otherwise look identical. And it can be constrained, right? It can be constrained in two ways. It can be constrained by graph type, by schema. We'll talk about that in a second. But it can also be constrained by implementations, because we recognize that there may be implementations which, only support a single label per relationship, like Neo4j does, or perhaps per node, right? And things like that. So here we also, via featureization, provide a lot of flexibility for implementers to basically decide where they want to be on the spectrum of generality of the property graph model. Access paradigm, pattern matching, of course, everybody's darling. This, of course, we share with SQL PGQ, right? The idea, I assume most people here on the call will know about that, is to use extremely intuitive ASCII art syntax to express the data that you're looking for, right? It has been called the best syntax for describing drawings ever invented. It was pioneered by Neo4j. But the idea, of course, since then has been adopted in OpenCypher and GQL and GCQL and PGQL, and hence got standardized now. And the important thing about pattern matching, and perhaps not everybody is realizing that it's not only applicable to DQL. GQL makes use of it holistically. We use it in DML, we use it in DDL, and of course, it's also imaginable that it would be used in textual serialization of graphs. So how does it look like? Of course, we have the core features that you can express with pattern matching: natural join, label expressions, essentially, conjunctive Boolean formulas over labels, filtering, so you can check if a path is a trail, things like that, bounded lengths. So these are stuff that you could also do with SQL with a little bit of work, although bounded lengths gets nasty if the bound is high, because it becomes very complex union queries. But it has also a lot of other features. First of all, patterns can be evaluated under multiple different semantics, under all paths, shortest paths. We may see cheapest paths in the future, different edges semantics, right? We do have, of course, support when you do shortest paths. You want to support unbounded transitive closure on the pattern level. We have support for nested pattern matching with optional filtering and a fancy new form of aggregation based on a concept called group variables along basically a path. We have a concept of a union or an alternative, actually two notions of union, and also paths can be treated as values. All that, of course, is more on the high level. When you define a language like that, you also have to take care of the low level. I already mentioned the type system. So let's talk a bit about that. So the GQL type system was an interesting challenge because the vendors at the table, we had everything there from we want static typing a la SQL to we want dynamic typing a la Python. And somehow we had to marry these two things. And so we support both. So the GQL type system supports static typing. And then it would be a natural match if you do that to, of course, only support graphs with mandatory schema, but also supports dynamic typing. And you could also have an implementation that doesn't even have graph schema, that only supports schema-free graphs, right? And so that's the approach. You have a choice between static typing, dynamic typing, or possibly combinations in your implementation. If you do static typing, there is the notion of optional constraining types, which is the kind of technical term for graph schema in the case of graphs, for data objects. And also a concept that's carried out consistently in the type system is this notion versus open, unrestricted types versus closed, specific, or you could also say refined value type. So you can say, okay, this is just any node, or no, this is a node where I know it has a label person and it has the field name of type string, right? And all of that is, of course, built on SQL-compatible foundations. And what it gets us, right, it gives us the right foundation in order to be able to define graph schema. And of course, more work is there left to do. We just saw the present, or I assume many people here on the call saw the presentation at Sigmod of the PG schema paper. So this is just the beginning of the end of that topic. And to show a little example here we create a, it should say there's a bug in the slide, no, there's not a bug in the slide, I'm sorry. Create a graph messaging of a graph type that's specified inline. And we basically, how do we specify a graph type? Well, we specify the nodes that are allowed in the graph as well as the edges, right? So here we have a node with the label person is allowed, and if such a node exists, it has to have a field called, or property called gender of type string, and a property called birthday of type date, right? And so we specify various nodes, and then we do the same for the edges, right? Person can like messages, for example, or messages can have tags, right? And in that way, you can structure, basically, or can define the structure of your graphs. And stepping a bit back here, what really is happening, I think, with property graphs, and the schema really is the raise of level of abstraction that we haven't had before, right? In the relational system, usually trade relations individually. In a graph database system, you can really treat sets of relations that hang together as an object, as a unit. Value types, I already spoke about that a bit earlier, right? We have chosen a compatible subset of predefined types from SQL. Character strings are always Unicode. We have byte strings. We have number types that you would expect Booleans. We have native support for nested data. GQL supports nested records and lists. It is up to implementation to which degree they want to support that also persistently in properties. And of course, we have notions of object references to graphs, paths, nodes, edges, binding tables, and things like that. Yeah, so that already kind of gets me through the blitz of the various facets of the 10-mile high view. I want to kind of begin to close by talking a little bit about a topic that's close to me. One thing that is very important when you design a language is compositionality. GQL has a lot of compositionality. It has procedure composition, it has interstatement composition, it has intra-statement composition, and as I already mentioned, it's already prepared for adding graph composition in the future. And here I include a query that shows a little bit of the kinds of complex graph workflows that we hope to enable, and I'm sure we want to go beyond that in the future. By showing an example of a multi-graph query that basically finds followers from two different graphs, builds a union, and then finds matching customers from a third graph that have the same email. So yeah, talking about the future, of course, now the first order for us is getting GQL out, and then it's implementations, and implementation adoption, of course, for the project to be successful. There are many things left to do. If you're interested in that, I'll point to the same paper as Keith, which is DCA 31 or Lex 36, both the same paper, and of course all the other fantastic LDBC papers we've seen in the DCA meeting. My personal feature shortlist, and it's really my personal list here, based on some perceived notions of completeness and urgencies, is of course that we continue to expand on the topic of schema, alteration of schema, constraints, keys, computed and default properties. There's a lot of things to do there. The topic of nested data support is hot, of course, and I think there's an interesting discussion there on, the relationship between native nested data and JSON nested data. And last not least, everything around analytics and AI. And I've begun to actually consider graph projection to be have to be viewed under that umbrella. But nevertheless, of course, also being an important topic in its own right, I think this is really where the future is pointing for graph query languages. Summary. GQL is a new graph database language standard that's about to be published, right? It's 550 pages with annexes and indexes. And we did not anticipate it would be that big when we started. I think Keith and me, like 3 years ago, guesstimated we would end at 300 pages or so. We, as Keith was already saying, aim to finish at the end of 23. Maybe we will bleed into 24. We'll see that. And I want to close here with a big thank you to everyone, because this is a team effort. Nobody does a thing like that on its own. To everyone helping making this happen. And the usual suspects, of course, are the folks in the W3, the national bodies, the vendors, and not at all least the LDBC community assembled here today. Thanks, guys. If you're saying something, Gabo, I'm not hearing you because you're muted.
So I said, very nice work, thank you, and open for questions. Mohan is first.
Hi, Stefan, thanks, nice talk. Just a short question, I think. So for the catalog, you said that it can be implemented in any way, and sort of at the discretion of the implementer, is that right? The catalog?
The actual structure is the question of the implementer. So the kind of how deep you go in terms of hierarchy is up to you. And
does it have to be queryable with GQL, or it can be?
No, we don't have that yet, so that's why we can avoid the question for the time being.
Okay, all right, thank you.
All right, another question from Roy.
Thank you, Stefan. Looking towards implementation, I was wondering what type of resources or artifacts are going to be provided. And I'm looking for something like a grammar file and also a test suite that checks validation.
Yeah, okay. So just briefly, thanks for that question. I should actually have gotten into that. So some things that come with the standard are actually going to be freely available from ISO, even if you don't pay for the standard, are the so-called digital artifacts. And that include at least an extraction of the grammar as it is written down in the standard. That may require some massaging in order to get it to the point where you can generate a parser from it, but we provide things like that. We also provide, you know, essentially files with all the error codes and implementation defined feature codes. So you get quite a bit coming out of the production pipeline that creates a standard. So now on the second part of your question regarding tests, I think that's outside of the scope of what we do on the ISO side, but maybe you want to take that one, Keith. I don't know.
Well, I was actually going to mention that on my presentation on the slides at the end that I didn't present, there is a link to the artifacts files on ISO, including the artifacts for associated with the GQL DIF. As part of the test, WG3 will not be writing tests, but it certainly would be great if a vendor or multiple vendors worked on expanding, say, some of the OpenCipher TCK testing for GQL, and that's a discussion I've been in on the edges of, but really can't say anything about when something like that might happen.
Thank you.
Okay, one more question from Alistair.
I just wanted to add to Keith's answer, because there is now a Basecamp, an LDBC Basecamp project to discuss SQL, PGQ, and GQL implementation. And the reason for that is because there are a number of people who are beginning to work in this area. So we've got people like Dominic and his colleague Damien in Białystok in Poland, who've produced a GQL grammar editor that is based on the digital artifact that was mentioned. Henglin and other colleagues within Ant Group have also been doing work on GQL grammar parsing, and there is a recently joined member of LDBC, Michael Burbage, who is, I think, in his mind, where he would like to go is to actually get the equivalent of the OpenCipher TCK. So that project is beginning to assemble a number of, there are other people as well who've done some work in this area. There's obviously work that was done in CWI, for example. So what we're trying to do is begin to assemble people who are interested in this topic and then see whether we can trigger a larger open source effort around tooling, maybe like the TCK taking off from what's already been done with OpenCipher. So the pressure, the capillary pressure is rising in terms of people being interested in this. And the reason I want to raise all of that is if anybody has any level of interest in participating in open source activity around either SQL PGQ or GQL implementation, get in touch, and we're going to try and make that ball roll faster. So thanks.
Right. Thank you.